Today we're going to start talking about calculating with sig figs, not just merely counting up how many are in a number, but rather how do we report our final answer. This might be a question you've asked yourself. How many decimals do I round to? I'm sure you've asked that question at some point in some class, and teachers are probably like, oh, just one or two. Well, in this class, guys, it matters. Okay? In lab, this is one of the biggest things that I will take points off for next to units, is not reporting your measurements or your data to correct sig figs. Okay? So this is where things might get confusing. When in doubt, go with the first rule. So we have two different rules. One deals with multiplication and division. The other deals with adding and subtracting. We're going to talk about multiplication and division first because probably 98% of the time, this is the rule you're going to follow. That rule states, guys, when you multiply or divide, you limit and round to the least number of total significant figures in a number. Okay? So least number of sig figs in any of the factors that you multiplied or divided with. Adding and subtracting will not be the same. So we're going to come back to that one in a minute. So if you take a look here at this example, first things first, guys, when you have all your numbers, do the math first. Get a big number and go out to a crazy amount of decimals. Keep, as many digits as you can. Then round at the end. That's a mental note you want to make to yourself is you always want to round at the very end. We will see later on when we get into multi-step synthesis problems, if you round early, your entire answer will be off by the end. It might be so far off that it doesn't even look like the right answer. Okay, so wait to round until the end of the problem. So here's our example. We had 23.0 multiplied by 432 times 19. They did it for you. You got 188,784 centimeters cubed. So keep track of when we're multiplying and dividing, guys, your exponent rules, how to get those units. Okay? When you multiply, you add exponents together. So when it comes to rounding, that's way too many digits. If you take a look here, okay, this number at the end is way too many digits. Did any of our original numbers have that many digits in it? No, so your final answer can't have that many digits either. Because again, you're limited on what tool you use to measure. You with me so far? Okay. So what we're going to do is we're going to look at all our numbers. How many sig figs does that first number have? 23.0. How many sig figs are in there? 3. So I'm just going to write 3 up above. Just kind of some bookkeeping for myself to keep things organized. 432 has how many sig figs? 3. And 19 has... So according to our rule, when we round and report our final answer, we're going to report it to the least number of sig figs. What was our least number in those 3? 2. So our final answer is going to have 2 sig figs because our least accurate measurement had 2 sig figs. You still tracking with me? Now is where I start to lose some people. You got this big long number. So I'm going to start at one end of them to start looking at what numbers are important. If I start over here at the right end and I just kind of focus on these last 2 numbers, is 84 centimeters cubed the same thing as 188,000? It's not even close, right? So what you guys will do, and this is a strategy, if it works, if you already see where I'm going, great. If you're not kind of track with me, then maybe this is going to help you get into that mindset until it clicks for you. It's going to click for each one of you at a different time. Don't give up. Keep practicing. Keep asking questions. Okay? So, 2 sig figs. That means I'm going to keep the first 2 numbers that I come across. It's going to help keep the integrity of my calculation. Then, the number after that, I'm going to just put a circle. That's the number I'm going to round. Okay? Does 8 round up or down? 8 rounds up. So I'm going to round this then. Instead of 188,000, it's going to become 190,000 centimeters cubed. Is that close to what we had? Yeah. Now, is it the same? Absolutely not. It's a little off. But again, we can only report our final number based on how accurate our measurements were that we used. So we can see that's quite a significant gap there of almost, over 1,000 centimeters cubed. But again, the proper way to write it is letting the people know that, hey, we were accurate to 2 sig figs. So this is going to be plus or minus a certain amount. It's going to be a little bit off of what the actual value was, but that's based on what we were limited to. Okay? How many sig figs? Is there a decimal in that number? No, so I have 2 sig figs there. If you're ever confused, you can rewrite it in scientific notation. This would be 1.9 times 10 to the 5th centimeters cubed. Pete.
When is significant figures important in science?
Every measurement you take, it's important. Every single measurement. So all the rest of the year, when we're taking and recording data in the lab, you've got to make sure you have correct sig figs. And that's going to depend on what instrument you're using. So if you're using a graduated cylinder that reads to the ones place, every single piece of data that you record needs to be estimated to the tenths place.
Okay. So that's the premise.
Exactly, that's the premise. So it goes back, again, right now we're only doing book work here. When we get into the lab and you start making it, it's going to start to click more with it. So we're kind of learning the theory behind it. We're going to put it into practice tomorrow in lab. Okay? Right, but it's dependent upon what you're actually using. So it's where it comes from is actually doing it physically in a lab setting. Right? We just haven't done that yet. Okay? So stick with me. If you're still confused, I promise, guys, it's going to make sense. Right, because if there's no decimal in there, we start from the right-hand side. Right, and we don't count them until we get to something else, just like we did yesterday. Yep. So the first thing, when you're given a problem, you're asked to calculate to correct sig figs, do the math. Always start with just doing the calculation and writing out a longer number. The rounding comes at the end. What do we get for number 1? 3.33 what? 041? 045. What's our unit going to be? Meters squared is what you should have. Meters squared. All right. Now we've got to report our answer, guys. We can't just have it out, because did either of our pieces of data go to 5 decimal places? No. So in a lab setting, think about it. Scientists are doing this all the time. They're trying to get their research published. So if they report an answer down to this many decimals, that's letting other scientists who are reading their papers know, hey, we were accurate to this digit. Well, if neither of your first pieces had that many digits to record to in the beginning, you're basically falsifying your data, saying you're that accurate. Okay? So you can only report as accurate as your least accurate measurement that you took. So, again, our rule with multiplying or dividing, we're going to count up we're going to go to the least number of sig figs in any of our numbers. The first number, 1.35, how many sig figs do we have? 3. Second number, how many sig figs? 4. So we can only report our answer to the least number, which in this case is going to be 3. So these 3 numbers are what I'm going to keep. I'm going to circle the 4th number. That's going to be my rounded piece. 0 is going to do what? Nothing. So basically, guys, I'm going to cross those out. And my actual answer that I would record, 3.33 meters squared. I want you guys to try number 2 on your own. Obviously, guys, there's no piece of instrumentation that we're going to use or that I even know of that can measure accurately down to that many decimal places. So again, if you were going to try to publish this, that's falsifying data that you actually were able to measure that accurately. So we can't do that. Our rule, we divided. How many sig figs does the first number have? 4. How many does the second one have? 2. So how many sig figs will we report to? 2. So it's these 2. Then I'm going to look at the third number as my rounding piece. Everything else I'm going to ignore. Just 6 round up or down. All right, so that's going to round up. So our final answer is going to be 25. And what's the unit going to be here? Meters. Okay? Any other questions I like the questions that you've asked. Any other questions with multiplying and dividing? We're going to get lots of practice with it. All right, let's go back and talk about the rule with addition and subtraction. So when in doubt, always go with the rule for multiplying and dividing. Look at the least number of sig figs. All right, chances are you'll be accurate with that and how you report it. Adding and subtracting, guys, is a little bit different. We're not looking at sig figs. We're looking at least number of decimal places. Okay, we're looking at only the points after the decimal, not before the decimal. So if you look at our example here, the first one had 2 decimal places, the second one had 0, and the last one had 1, and then the third number had 3. Well, where do they report it to? 1 decimal place, okay, because 46 had it. So if we take a look here, do the math. 12.01 plus 35.2 plus 6. How many decimal places did the first one have? 2. How many decimal places did the second one have? And how about the last one? So how many decimals will we report to? 0, because there was one that had 0. When you add those up, what do you get for an answer? 50.2. We would round it to 53 milliliters. All right, I want to give you guys a few minutes. Go through and finish 1 through 10. It would be 26.6 grams because you had 1 decimal place in 28.9. Moving on to the next one. You multiplied them all out. So we're multiplying. What's our rule for rounding to correct sig figs? We look at the least number of sig figs. So again, it's always least number, guys. If you multiply and divide, it's least number of total sig figs. Adding and subtracting, it's least number of decimal places. So we have 2 sig figs here, 2 here, 4 there. We're going to report it to 2 sig figs. 2 is going to round down, so it's 6.7. What's my unit going to be? cm cubed. All right. Somebody give me the answer to this one. I had it wrong on my slide. I had it as division. You had it as addition. What's the long answer there for number 6? 3 what?
3.35. Oh wait, the long one, I don't know.
3.351. That's it. So we're adding here least number of decimal places. There's 2, 2, 3. So we should go to 2 decimal places. You should have 3.35 centimeters as your answer there. 37.5. Now this one is a more challenging one. How many sig figs would you report your final answer to? 1 sig fig, because you had 1 sig fig. So we're multiplying or dividing. We're dividing here. How would you get that to 1 sig fig? Right. So notice, and this is what I think, what Pete and I were talking about when he was asking earlier, guys, when you have large numbers, okay, and you're less accurate, you're going to be rounding so it does not look even close to what your number was. When you have smaller numbers, meaning decimals, that's where when you round, it's still going to be pretty close. Okay? So 37.5 is significantly different than 40. But the bigger the number is, the least accurate you are, that's where it's going to be. Do the last 2 really quick. I'm still going, so you shouldn't be packing up yet. Just saying. Next one. 0 decimal places, because you have 0 on that and you're subtracting. So this is going to be 55 kilograms. The next one you multiplied, so least number of sig figs, we have 4, 3, 2. So 2 sig figs, I'm going to have 0.0017 millimeters cubed. We will come back and do number 10 tomorrow, and I will show you the correct way to do it in your calculator.